Okay, guys. So, hello. Yeah, my name is Theodore. I'm actually a business analytics major. So, are there any BAs here? Just wondering. No BAs. All of you are like CS or. Okay, great. So anyway, yeah, I'm a BA. Not the biggest expert on this kind of thing, but okay lah. Hopefully, I can teach you something today. Uh, right. So today we're going to be covering deployment. Actually, you guys, in the context of your project, actually, you all probably are still very far away from deployment. I know you all are like milestone one is like requirements, right? So you're at like step one, far away. You still have a long way to go. But anyway, yeah, mission controls are on now. So yeah, hopefully you will still remember what to do when you eventually get there. Right. So first thing, server access. That was what I needed all of you to get right first. So how many of you actually managed to get in? Right now, I'm going to introduce you guys to this thing called Docker. So basically, when you're doing server deployment, right, usually there's a very high chance you are going to mess the server environment up. So nowadays we have some tools that make it easier for you. Have you ever used VMs, virtual machines? So Docker is a little bit like a VM, similar but not exactly the same thing. So okay. Yeah. So the reason why the guys who made Docker is because they want to make deployment a lot easier. So ideally, when you want to deploy your application, right, the easiest way is you want to have something like that. It's just Docker run my application done, right? But of course, when you actually deploy later on, you realize that, yeah, even getting server access becomes very complicated. So yeah, it's not always this easy, but Docker brings it quite close. So yeah. So anyway, the problem usually with deployment always is you have a lot of these different kinds of software, different kinds of libraries. They all have different dependencies, and they all need to run on a large number of different kinds of computers. So you're developing on your own laptops. Eventually, you want to deploy on some server. Eventually, you need to put it onto a production cluster, all kinds of things. Okay, so you need to deploy it across everywhere. And the problem with this is that on every single one of these infrastructure platforms, you need to figure out again how to install all of these different software, all the different dependencies, all the different like binaries and whatever, and it becomes basically it's a big mess that is deployment. So that's why I think deployment usually is not a very easy thing to do, but hopefully with Docker it makes it easier. Yeah, so basically what I just said is like for every single piece of software that you want to deploy on every single platform, you need to have a customized solution, which makes it very, very complicated. So the idea behind Docker actually it goes back to cargo transport. So if you think back to cargo transport, actually we have faced a similar kind of problem, but in the real world. The Docker is in the software world, right? In the real world, we have actually faced a similar kind of problem, which is when you're talking about trade and you're doing shipping, right? The problem here is that you have all of these different things that different people are trying to sell, different things that people are trying to trade, and every time you try to transport them, you need to figure out a new way. How are you going to stack these things? How are you going to transport these things? How are you going to move it around? And so in the same way, it's also very complicated. On every single one of your transportation platforms, be it, if you want to put it on a ship, you want to put it on a train, you want to put it on a truck, you need to figure out a new way to load these things onto that platform. So it's kind of like the same problem, but this is like analogous to real life. So the solution that they came up with was actually, the shipping container, which is basically you put everything into one big box. It has everything is inside. If that thing needs refrigeration, you even have a refrigerated container. So it's like dependencies included. And now you just need to take this box and make sure that this box can be transported across all of the different platforms. So you can put your box onto a container truck. You can load it onto a container ship, or all your cranes, as long as they can lift this box, that's done. Okay, so you solve the problem across everything at one shot. So that's basically what Docker is trying to achieve. Basically, what you're trying to do here is you're trying to make a box that you can put all of your software inside, and with all the dependencies, and you run it anywhere, and it just works. So that's the idea, and yeah, so that's what I'm going to be covering today. So yeah, just a slightly more technical explanation. Docker is actually based on Linux containers. So Docker itself did not develop the technology, but it's actually based on Linux containers, which is, it became a feature of the Linux kernel somewhere back in 2008. And yeah, so basically Docker they built upon this technology, and it's sort of like the management platform where you can, all the commands that you can easily use to manage all of your applications when you try to do deployment. Yeah, so just a summary. Basically, you want to handle all your dependencies. You don't want to be messing around with, installing all kinds of different things on different platforms. And on every single platform, you install again. You develop once on your laptop, and it runs on any computer, any server. And at the same time, you can keep your server environment tidy, because if you just want to get rid of, this application, you already put everything in a box, you want to get rid of everything, you just delete the container and it's all gone. Yeah, so there's actually a Docker image repository. I'll cover this later on. There's a whole section on that. Okay, so sounds great, right? So how do we get started with Docker? There are two things that you need to know. It's quite similar to VMs actually. You basically have images, which is kind of like a snapshot. And then you also have containers, which is like the running instance. So the image, of course, you usually only have one of that. And from one image, you can start as many containers as you want. So you just instantiate as many containers as you want. So for example, if you are deploying some, I don't know, some backend software, you find that one instantiation is not enough, it's taking too much CPU or something. You just copy it as many times as you want. It's one of the uses of Docker. So, okay, so we're going to get started with some of the demos right now. First thing you have to know is Docker commands have a lot of flags. So if you thought the SSH one was bad, this is a lot worse. It's going to be, yeah, basically it has a lot of flags. The Docker run command is the probably going to be your most used command. Basically, the Docker run command does everything. It just basically takes your image and it runs the container for you and gets everything started. Okay, so first demo, how to host a simple website. Okay, so I'm just gonna do this. So, okay, so now we're just gonna jump in and do that. So right now, let me show you the files first. Okay, so before this workshop, I actually went and downloaded like some simple website. Of course, ultimately in Orbital, your job is to write whatever this website or web app is supposed to be. But basically, yeah, I just downloaded some generic website. Okay, so this is currently on my computer. You see up here is index.html. Yeah, this is currently on my computer. So it's just a generic website. Now the question is, how are we going to take this and put it up on the internet so that everyone can see it? Very, very standard thing that I think all of you, especially the computing people, should know how to do. So, okay, so we're going to fire up the server. No, the rest of the stuff. Okay, so first thing we need to do is, do you all know what Nginx is? Nginx. Okay, so Nginx is basically this piece of software that hosts your website on the server. So you put it on the server when you go to your browser and you press, you type in your URL or whatever, you press enter. When it reaches the server has to handle that request, right? It has to handle that request. And that request is usually for a website is usually handled by some sort of web engine. Nginx is just one of them. There are some others that you can use as well. So in my case, I'm going to use Nginx. Yeah, so basically Nginx, this piece of software, right? It used to be that you had to deploy it directly onto your server. That means you go and install like apt-get nginx or whatever inside here. But now, since I'm going to be using Docker, I'm going to basically pull the Docker container from a repository somewhere, and it's going to contain nginx. And then we're going to attach it to a website so that when you use your browser and you send a GET request to the server, this piece of software is going to respond and it's going to serve up your website. So it's going to reply with your index.html and whatever. Okay. So that's just the idea of what's going to happen. So let's do that. Command is actually that. Okay, so later on, if you want to try this yourself, it's in the slide switch. I'll put somewhere. Like I said, there's a lot of flags. Okay, so let me just run over like what this command actually does. Okay. Okay, so the name here, right? That's just the name of the container. So you can just be quite simple, quite self-explanatory. Dash P is actually going to be for the port. Do you know what ports are? You guys know what ports are? Okay, so basically when you how do I explain this? Basically, each one of your computers, right, on the network interface, there are you can establish like a number of different connections, and each one of them is going to go through in this thing called is a port. In that sense, so it's like a connection point. And on every single one of your network interfaces, you always have exactly 65,536 of them. It's 2 to the power or something. I don't know what it is, but yeah. So yeah, 65536. Yeah. So you have port 0 all the way to 65536. You can use any one of them. It doesn't matter. Any number is fine. You can just randomize it. But yeah. Here you see that I'm using port 1234. So later on, when I try to go to this website from the browser, right, I use port 1234. I know that you guys normally, when you go to a website, you're thinking, well, it's www.something.com, right? It turns out you can actually also, you go to your browser and you type in your the IP address. It will also send a GET request. So when you put in the www.something.com, basically what that is doing is it makes a request to another server somewhere. It's called a DNS server. And this DNS server is going to convert it into the IP address. So it's basically the same thing. Okay. So in this case, I'm not going to do the whole domain name thing. So you're not going to see www.something.com, but that part is simple. You can figure it out later. So anyway, here I'm going to be using port 1234. The colon 80 over here, this is for port 80. The reason why we're using port 80, you guys know what HTTP is? Hypertext Transfer Protocol. Oh no. No, for this computer, I know what the answer is. For some of you guys, I really don't know. Okay, so anyway, where did it's gone. It's very irritating. Whoa. Okay, so apparently it's running already. But anyway, yeah, let's continue. So where was I? The 1, 2, 3, 4 to 80, right? So this thing is basically like a port mapping. Basically, what this thing is doing is I'm telling the server map port 1, 2, 3, 4 on the server to port 80 on the container, on the box. So the box itself also has, all these ports. And basically now I want to map port 1, 2, 3, 4 on the server and map it to port 80. Okay. The next part, this dash v, that thing is actually what we call a Docker volume. So this thing is sort of like basically it's linking the directory. So inside the container itself, there's also another directory. There's another directory tree in that sense. It has its own files and everything within the container. And so basically what this thing is doing is it's mapping this particular directory, which is the orbital site, and it's mapping it to this directory within the container. So this directory inside the container is actually where the container is expecting to find the website, the index.html or whatever. You can change it in the configurations, but this is the default one. And now I'm going to have this directory over here, which is where I'm going to put my website. Okay. So later on, when I put my website inside here, I go to the browser, I go to this IP address, I should be able to see the website. The colon arrow basically makes it read only. Dash D, that's something, just ignore it for now. And nginx, this is the container name, as in the image name, not a container name. So this is the image name that we're going to pull from the repository, basically. So this is basically what you're going to do here. You're going to run the nginx software and do all the configurations necessary so that it's going to point at this folder. And when you access the server, it should go inside this directory and find your index.html. Okay. Right. So now we need to put the website inside there. So I'm going to get out first. Okay, so the site is currently stored inside here, okay? So now what I need to do is I need to copy all of these files onto the server. This is using SCP, so let's do that. -R is basically recursive. So recursive is basically for you to copy the entire directory. So it's like copying one file versus copying the entire folder, okay? So that's what the -R flag does. Oh no, what's this? Cannot create directory. Okay, hold on. Oh, is there nothing inside here? What's going on? Okay, hold on, let me think about this. Wait, did I get it the other way around? Ah, okay, sorry. My bad. Okay, so yeah, it's gonna copy everything onto the server. So let me just check that it's inside there. That is not right. Okay, so now all of the files are correctly on the server. So now if I go to my browser, right, and remember this was the port. The port, you have to put it there. It's actually the colon. The colon is for you to specify the port. I'm gonna do that. And something went wrong. Okay, so well, but at least we know that Nginx is responding. It's just that for some reason it is not hosting the files correctly. So I'll debug that later. We'll move on to the next example. Yeah, I don't know why it's doing that, but okay. Okay, so anyway, now that was all very simple. Let me get the slides up there. So okay, not exactly simple. A little bit of debugging required, but yeah. So basically, this one, I think y'all kind of get it, right? Are y'all okay with this so far? I know it didn't really work, like there was a 403 forbidden, but yeah, I'll have to go and fix that later on. So far, what we managed to achieve was we managed to get Nginx running on the server, and we managed to get it to respond. It's just that for some reason it gave me forbidden, so I'm not sure why it does that. Okay. All right. So that was all good and simple, but now for your particular project, right, you are going to be writing actual server code. So it's not going to be like just pull this piece of software from online and just run it. You are actually going to be writing your own software, right? So you need to figure out how to put your own software into a container so that you can run it on the server. Okay, so this is generally the process, how it's going to work. So you're going to pull an image. So let's say you write your software in, what you're using, Meteor, JS, Express, something like that. So you pull an existing image that contains the basic binaries, let's say Meteor or Node or whatever. And then you're going to install all of the dependencies that you need, all the libraries that you're using. And you're going to make all the configurations that you need inside. Usually there shouldn't be too much configuration unless you're touching a lot of things. But yeah, usually it should almost work out of the box. And then you're going to add your server code on top of that. And then you build your image. You run the container from the image. And then finally, from there, you can redistribute your image as many times as you want. Okay, so this is generally the process. It looks very long here, but actually, honestly speaking, in terms of the number of lines that you have to write, it's far less than that. It depends on your specific application. But yeah. So anyway, for this particular case, right, I've gone ahead and actually written a very simple server in Python. Let me show that to you. Okay, so this is just some very simple server code. Basically, maybe it looks kind of complicated, but basically what this is going to do is there's a database connection line over here. You can see this. So what this is going to do is it's going to connect to a database, and when you send a GET request, that means you go to your browser, you type in something over there, you press enter. There's a HTTP GET request. It's going to take a string from the end of the GET request, some parameter, and store it into the database. Okay, so I think that you guys basically what you are trying to do when you are making applications, you're basically going to write some server application, some front end, then you're going to use some database, right? And then you're going to basically need to read and write from that database, store some information. That's basically the essence of an application. Okay, so this should this is just like a replacement. It's just a generic kind of server. Of course, later on, your own server should have a lot more code than this. So yeah. So right now, what we're going to do is we're going to put this into a box. Like I was saying just now, we're going to put this in a box so that we can run it as a Docker container. And in order to do that, you need to create this specification script. It's called a Docker file. It looks something like that. Yeah, so basically this. So let me go back to the slides. So basically, yeah, these lines are what you saw just now, okay? So all these lines are from the Docker file. So basically what we're going to do here is the first line from Python :3. Basically what that's doing is it's going to a repository. It pulls a base image that already contains Python pre-installed. Later on, I will show you where all of these comes from. There's a lot of base images and whatever that you can use. Sometimes people even like there are even images where people have already pre-installed some things. Then you can just use that. Like they pre-install some libraries for you already. They compiled it. Then you can use that as well. But yeah, this is one of the official images for Python. So we're going to pull that from the repository. The second line, pip install. How many of you use Python here? Have you ever used Python? Okay, so you know what pip does, right? So pip is basically is the Python package installer. it basically installs all your Python packages for you. This is a command line that installs your Python packages. So this PSYCOPG2, that's basically your database connector for PostgreSQL. Okay. So that's what the second line is basically going to install the database driver into the Python installation so that now your Python can interface with PostgreSQL database. Third line is basically for you to copy the code into the container. So just now you saw the code that was written, right? The server code that basically it defines what your server is supposed to do. Now you need to take that code and you need to put it into the container as well so that later on you can run it. So that's basically what it does. You see dot. I know how many of you know what the dot means? The dot means just this directory. Okay, so the local direction, this directory. Slash means the base directory. The squiggly line is the home directory. And dot is this directory, like your current working directory. Okay. So dot there it's dot because it's this directory from this computer into this directory inside the container. Okay, so copy from this directory here to this directory there. That's what it does. And then fourth line actually is not necessary, but I just put it there just in case. So basically what that's going to do is it's exposing port 3305. Remember what I said about ports just now? You're going to expose port 3305 so that you can access the container and via port 3305. And that is supposed to do something like when you access it via that port. Last line is equivalent to, if you are running Python programs on the command line. The last line is basically for you, it's similar to going to your command line and typing in Python run simple server.py. Python this, okay? So it's similar to that, except this is in the Docker file syntax. That's why it's written this way. I'm not sure what actually will happen if you just put Python simple server.py. That might work as well. So basically, what this does is it tells the image, when you start this container, run this command. So the moment this container starts, it'll run the server. Basically that, okay? And so yeah, so once you have all of this, you can build the image, the container image. So let's go ahead and do that. I don't have the files here, so I need to copy them in. Okay. Okay, so now the files are here. We need to build a container using these two files. And you do that using this command. Oh, no. The command over there. Where's my mouse cursor? This one. Okay. This command over here. So this is what we're going to use. Basically, this one, I'm actually not sure what dash does, but you need to have it there. And simple server image is just going to be the name of the image. So you can name this anything you want. This is just anything you want. And the dot is for this directory again. Not sure how long this will take. So right now, what it's doing is downloading the Python container from online, and that's the first step. Wait for it to be done with this. Are any one of you guys trying this, or you're gonna try this on later on? Okay, so just pay attention for now. Okay, you can see step 2 is running pip and blah blah blah. Okay, so now the container is built. If you go to Docker images, you should see your image is over there now. Your image is over there. Okay, so simple server image. So now, once you have this simple server image, in order to deploy your application, what you need to do is 2 things. You need to deploy one container for PostgreSQL. The second thing you need to do is deploy, you need to deploy this simple server image. Okay, so let's do that. Skip that for now. There's actually a different way for you to create these containers, which is basically you run the container first, do everything inside, and then save it. So that's a different way. The Docker image is kind of like it actually kind of does the same thing. It's just that you scriptified it. If you want to do everything step by step, you just want to do it in an interactive shell, you can actually do this, which is basically you start the container first, go inside the container, and then you do things step by step. And then you commit the container to an image. So this is basically sort of like save the container into an image. So you take a snapshot. But I'll leave you to try this if you want. Okay, so yeah, basically this is what we're going to do. Okay, so this is going to be your so-called server setup. Just a simple diagram that illustrates what you're going to do. So you have your Docker engine over here, your host OS, and you're going to put inside your one container, you have your Python. It's going to run the Postgres driver that we just installed, and then the server code on top of that. Okay, and in the other container, we're going to have PostgreSQL, which is your database. And then we're going to link these two. The thing is that these two containers, remember, these two containers need to talk to each other, because this container is going to is going to save data into the database, which is inside this container. So these two containers need to talk to each other. Of course, one way that you can do this is, if you just don't want to have this link, you can just have it go through the physical network, which means this is just one container by itself. It acts like its own server. This is just one container that by itself. It also acts like its own server. And every time this container wants to save things inside this database, or it wants to read anything from this database, it just goes through the network and then finds the IP of this computer and then comes back down here again, and then finally ends up at this container. So for example, let's say you deploy this on port 3305, and then this one you deploy on port 5432. Goes up, goes through the IP, goes through the router, whatever, all your physical infrastructure. Maybe you go through the internet, and then you come back down, and then you finally end up at this container. Okay, but the reason why we don't usually do that is because it's quite slow. So if, for example, you have a lot of database traffic, right? You want the link between this container and this container to be as fast as possible. And if they're already running on the same machine, why not you just link them? Like, you just have a virtual network bridge in that sense to link between these two containers, so that they can just talk to each other within that particular machine itself. So this is what we're going to try to set up on our server. Yep. So what I said just now, first thing, run the PostgreSQL container. This is the command for that. And then after that, you need to run the application container, which is all your Python code and whatever, or in your case, JS, anything, and link it to the database container. This one has actually a little bit of complication. So you notice here, I'm using an alias. See here, there's like this thing. Basically, this Postgres, right, is going to point to this container. So this is one container up here. this link thing here, right, is basically saying, okay, so we want to link to the Postgres container, but we want the host name of this Postgres container to be PostgresDB. And this is important because when you write your code, your server code, yeah, if you remember the server code up here, yeah, this host name needs to match up, okay? And all the other stuff as well, you need to get it right. If you don't get it right, your connection is not going to work. So this one is basically going to be the container alias that you are setting just now. You have your username, your database name, the port is 5432. This one you also have to set. And of course, the database password, okay? Right, so let's do that. Yeah, so let me just run through this command and pass everything for you. So the port, again, this is basically mapping the server port to the container port. In this case, we're just going to use the same thing. So just 5432 to 5432, that's fine. 5432 should be not used. This -e is actually the environment variables. So in this particular container, right, if you go onto the, if you go and look for the instructions, actually they say that you have to specify some of these environment variables. What are these environment variables? Namely, the database name, the database password, and the database username. In this case, I only specify the password. So the username and the database name is going to be set to default. The default is Postgres. Okay, and -e is just there. Postgres is going to be the image name. So we'll run that. And it's going to pull the entire database software from a repository. Okay, so that's done. So now we have a database running on this particular server, and you can access it via with the username and password and whatever, and you can access it via port 5432. So now we need to run that other container which we just created just now, which is the simple server image. You all can remember that. So let me do that. Okay, so again, let me. Okay, so yeah, just pass this the name of the container, simple server. Link this to the other container via this alias, the port 3305. And of course, yeah, the name of the image. So we can just go ahead and run that. You notice that this is listening on port 3305, right? You also have to get this right. This is actually from here. If you see this over here, 3305 over here. Yeah. So this is basically telling this server, this piece of server code, right? I want it to listen on port 3305. Normally, you would have it listening on port 80. Port 80 for HTTP. But in this case, I'm specifying I want it to be on port 3305, some arbitrary port lah. So yeah, let's go ahead and run this. And it's done. Okay, so right now, the thing is now you need to sort of go and see what's inside the database, right? In order to know what's going on. I actually included this in the slides. You can try this. Yeah, if you want to see what's inside a database, not so simple, but yeah. Okay, let me just do that so that you can actually see the database. Okay, let me try to explain this command to you. So basically what we're going to do here is we're actually running another container just to access a shell so that we can go and get into this database. And this container actually it's actually the same image. It's actually from the same Postgres image. Except that you see all this extra stuff at the end over here, right? PSQL, blah, blah. PSQL is basically a shell. It's an interactive shell for you to access the Postgres database, okay? So with this interactive shell later on, you can type some commands to see what's inside the database. I don't actually know what all this dash U is. This should just be, it's some parameters lah, basically for PSQL to work. It's for this particular command. So this is like going to some command line, you type in PSQL, all this stuff, and then I'm gonna guess that probably it's for the database name. Oh, this is probably for the user. Yeah, this one is probably for the user, and this is probably for the database name, I'm guessing. So let's go ahead and do that. The password is dbpass. Okay, so now we are inside the database. So you can actually, the database right now is actually blank. There's nothing there. So if you type select star from, you guys know SQL? I think you all probably haven't had to write it, right? It's really painful, but yeah, okay. Okay, no, let me do this. Okay. Oh, wait. Okay, so now you can see, right? The database currently has nothing in it, okay? I just created a table called strings. It's supposed to match up with that server, if you remember the server code. Let me go to the server code. So this server, right? Every time you send a GET request to this server, what it's going to do is it's going to insert into this table values, blah, blah, the format of this thing, okay? So it's going to insert something into that particular table. So right now, that table has nothing. If let's say we go to the browser now, and I call up 3305, okay, there's still nothing inside. Hold on, give me a moment. What the heck? What is going on? Oh, wait. Okay. Right. So now if you go to the database, right? Yeah, see? So now we stored a string inside there, okay? So basically what we did here was we go to my other command line. Basically what I've done here is I've used curl to send a GET request via the HTTP protocol to this server at this IP address, access this port, and send it with these parameters. Where did the parameters go? The parameter. So the parameter is string equals hello. Okay. Basically, this string equals hello is going to go inside the server code in Python. Where did that go? It's going to go inside the server code basically, and then it's going to pass this particular parameter. It gets the hello over here, and it saves that into the database. So that's all that it does. Okay. So success. Now you have a very simple application. What it does, it just takes a GET request from somewhere, and you can store something into a database. So yeah, this is very, very basic database interfacing, but we have achieved what we wanted to do. So from here, basically, if you're writing, say, a larger application, obviously this is not a very nice front end. You know, if you have to use a command line to go and do something, but that's because my application has no front end. It only has a back end. It's just a server. So it's just a server code. You have to use a command line to go and poke at it. But if let's say you want to build a front end, you can build a front end that basically you type in inside a box somewhere, and then when you hit enter, it sends this particular request with string equals hello at the end, and it's going to achieve essentially the same thing. Okay. So yeah, so are you following so far? Okay. I lost half the class by now. Okay, so let's move on. Yeah, so right now, right, if you want to inspect what is going on your server, you actually can just drop a summary, a very simple summary. So this is going to give you an overview, okay? Docker PS. It's going to give you an overview of what is currently running on your server. So let me show you that. Oops, wrong one. Yep. So this is just an overview of all the containers which are running on the server. So you can see here, it's actually supposed to be a table, okay, but because right now it's a bit too long to fit on the screen, so that's why it's wrapping to the next line. So the container ID, of course, the image is the image of the container, the command that was first run when you started up this container, when it was created, the current status over here, the ports, 00000. Actually, okay, the ports, right? You can actually map a specific network interface. That means if let's say your particular server has got different connections, like for example, one of them is Wi-Fi, one of them is say a LAN connection, and you want to differentiate between these, when you do the -p flag, you actually can put a IP address over there, and the IP address being for that particular network interface. But if you don't specify it, then it just maps it to 0000, which is everything. So it's going to be listening to port 3305 on all the network interfaces. So it doesn't matter which connection it is. It's going to be everything. So 3305 mapped to 3305. This one, we mapped the database just now. It was 5432 to 5432. This Nginx was the website that we hosted, but didn't really work. And yeah, port 1234 to port 80. Okay, so that, and this is the container name. If you don't specify a container name, it actually comes out with some random nonsense. Like in this case, it has put there Brave Bash Skara. Okay, so normally try to name your containers. Okay, it does give somewhat nice names. I've seen a lot of very interesting random names that it gives to the containers. But yeah, try to name your container so it's easier for you to remember. Okay, let's move on. Okay, so you can see that there's one last thing over there. You can actually inspect the container link using that command. I'm not going to do that. Basically, you're going to get this. It's just basically going to tell you, so the Postgres container is currently being mapped to the simple server as this alias. Okay, so that's all. This, if you want to inspect the links on the container. Okay, so linking, right? This particular linking feature, which I just showed to you, this is actually a legacy feature. But I think for you guys, probably you want to use this feature because it's easier. The proper way to do this in Docker is actually to use Docker networks. So Docker networks basically it's supposed to emulate how you set up your physical networks in real life. So for example, you have like your, what's that thing called? The router or the switch. You have a switch or something, right? And then you connect all of your servers to it. And then each one of these things is going to have its own IP and whatever. So it's this Docker networks is supposed to emulate the way that you connect these things in real life. And I think it has some advantages over linking. One of them being that if you are using linking, every single time you want to link a container to another container, right, you realize that the link flag was part of the run command, which means that there isn't really a way for you to take a container that is already running. It means something that you already started beforehand. You use run and then you ran this container. And then if you want to link it after that, there's actually no real way for you to do that in Docker. So that's just a small caveat, if you will, of using the linking feature. So Docker network sort of like lets you get away with this. Basically, you can create your own networks, and then you can basically put your containers into these networks. And in that sense, you group them. You group them together so that they can, specifying which containers are allowed to talk to one another. Okay. So yeah. Yeah, so this is just a simple diagram of something that like what you might try to set up if you were doing a more complicated setup. But in your case, you shouldn't need more than 2 or 3 containers. Usually, if you're using Meteor, it's going to be 2 containers. You just have application and database. If you're using, I don't know what else, then normally you will have front end, one of them to host the front end, which is going to be some website or some web app or something. So you have the front end, your back end, and then your database. So normally you shouldn't need more than 2 or 3 containers. And yeah, I would suggest you use the linking feature. It's easier than this, easier than Docker networks. But anyway, Docker networks, if you want to use it, I'll let you try that yourself. The commands are something like that. So you create the network, give it a name. In this case, you just call it simple network, and then you connect your containers to the network. Simple server, connect to network, Postgres, connect to network, and so on and so forth. The other thing about Docker networks also is that you realize that when you use linking, right, the link is actually one directional. So just now we linked from this simple server to Postgres. It doesn't actually work the other way. So if let's say the database server for whatever reason wants to communicate with your server, it can't do that because it's actually one directional. So there is no way for the link to go back the other way. But if you're using Docker networks, all the links are always like duplex. They're always two-way. Okay. Yeah, so the last command is just for you to inspect it. You can try all of this. The output for the last command is going to be very long, so that's why I didn't put it inside here. But anyway, after you do all this stuff, you connect. You can try that. You can just run the commands, Okay. So let's just use these containers since we already have them running. Okay, so yeah, so this is what we are going to get if you do that. Basically, this is actually a bridge network, and yada yada yada. So simple server is connected, and the other one is Postgres. Yeah, so under containers, you see a Postgres connected, simple server is connected. Okay, so now these containers also likewise they can talk to each other, and they all have their own IP addresses. So in this case, this is that you can access it from this IP address. So if let's say now I use Docker networks, right, and I want to access it via this particular IP address, I can actually go to the code. That's my code. Okay, so the code. So let's say if I put that IP address inside here, that should also work. Yeah. So yeah, that's it. So right now you should know, hopefully, how to set up, the containers, how to create your own image from your own code, how to run the containers on the server, and how to connect them together so that these containers can interface with one another. And you can store things on a database and so on. So that should be pretty much sufficient for you to go about and create your own application. Okay, yeah, this is just here for your reference, actually. Some other Docker commands. Docker pull is actually for you to pull an image from the repository. I'll show you the repository later on, don't worry about that. Images just shows you a summary of all the images that you currently have running on your server, or not running, but currently installed. There's, of course, you can stop your containers, start your containers, restart your containers. RM is for you to remove an existing container. RMI deletes the image. You normally don't use this unless you want to save space. You need to save your hard drive space on your server, then yeah, sometimes you have to use that. PS shows you an overview of all the running containers. I already showed that to you just now. And Docker exec. Okay, let me show you an example of why you would use Docker exec. If you remember just now, okay, over here, right? See, it says access the container via the shell. So each one of these containers, right, inside the container is actually sort of like a virtual machine by itself. In a way, sort of it's not a virtual machine, but yeah. So each one of these, you can actually access the shell, and just like any other Linux terminal or any other bash terminal, you can install things, you can use Vim, Notepad, whatever, all from inside there. So yeah, let me show you what happens if you actually run this. Okay, so the reason why we need to put this /bin/bash over here, right, is actually because this is where this is the default location for where the command line is stored. So don't worry about that. Usually you just put this. Of course, you can use Docker exec to do other things. Like for example, if you wanna start a particular application within a container, you can also use Docker exec for that. So if we run this, it gives you this. Notice that here, see that this is actually now different. This is actually the container ID from just now. So now we're in a different shell. This is a completely different environment that you have entered into. I mean, from the command line, it may not look so obvious. It may look like, okay, I'm still on the server, right? But technically right now, you're in this server on this container, okay? Yeah. You want to know where that ID is? Yeah, it's this one. Simple server. So it was this ID over here. So that's the container that we have accessed. In order to get out of this, if you get out of this by pressing Control C, which is what you would normally try, Control C is actually going to shut down the container. So you don't want to do that. Sometimes, especially if you're running server applications, right? Sometimes you go in, you configure some stuff, you do some stuff, whatever, use whatever commands, install libraries, anything. When you exit, you want to leave the server container running, right? So once you're done, actually the proper way to do that is you press Control P, Control Q, and it will bring you back out. And you'll leave the container running. So you can see that it's still running. If I had done something else, let's say I Control C. Oh no, Control C actually don't do that. Maybe we'll try exit. Okay, it's still running, so whatever. Maybe it doesn't matter. But it used to be that if you press Control C, it will actually shut down the container. So yeah, just take note of that if you ever need it. Back to reference. I think I went through most of this. Docker attach. Docker attach is actually supposed to do something similar to what I just showed you. It's just that for whatever reason, when I tried it, sometimes it doesn't really work. Like it doesn't bring up the shell. It just gives you nothing. Like it doesn't respond. So that's why usually when I access containers, I use Docker exec. But in essence, it should do the same thing. Like you can try using attach if you want. Okay, so who is using Meteor? Okay, so Meteor is actually pretty cool. What they have actually done is they have given you this script over here, Kadira Meteor Hub. Let me click on that. Okay, so Meteor Hub is basically a script, okay? And what this script does is it's going to build your entire, as compared to what you had to do just now, which is, you had to go and set up all your containers, get all the flags right, blah, 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 and set up everything. Meteor Up, basically all you need to do is set all your configurations into a JS file. And once you've done that, it should just, the script will just run and it should set up everything for you. Okay, so you don't have to do any of those like Docker commands. This thing will run the Docker commands for you. But you still have to configure it correctly. You still have to set the IP address and your private key and your public key, and you have to tell this thing how to access your server, and then all the password. If your server has a password, then yeah, that makes things a bit troublesome. But basically, this thing is just a script that is supposed to do everything for you. And it's, in fact, I think one good thing about this thing is that it's not just for you to deploy on one server. So if let's say you want to deploy your Meteor application across a few servers, right? Or you want your MongoDB database, Meteor uses MongoDB. So you want to put your Mongo database on a different server from your main application. Here it's very easy to do that. If you were to do that using like Docker commands, you have to go individually into each server and then set up the container on each server and then get them to communicate with each other over the network, right? But if you use this, you will just have this file where you can specify, it's a JSON file basically. You can specify all of the IP address and the port and whatever and everything that you need to get the container running on the server. And with just a few commands, you should be able to get everything running. So I don't actually have Meteor installed here, so I'm not going to demonstrate that. Yeah, but basically you can install this. For those of you who are using Meteor, you get it from the Node Package Manager, NPM. You install global, install map. It's a short form for Meteor, so map. And you go to your Meteor app directory. You have to create this directory called .deploy. Then you go inside .deploy and you map init. So map init is basically going to create two files. One of the files is a specification file for all the libraries that you need to run for your Meteor application. Map.js is the second file, and that second file basically contains all the specifications for your server, which is like, so what's your public key? I mean, what's your private key? Where's your private key stored? What private key should it use to access your server? What's the IP address of the server? What port to set it up on? What container image to use? All of this is going to be configured from inside this file. Okay, so yeah, I'm not going to demonstrate this. I think we're out of time for now. Yeah, so this is the next section.